question. It says, a stone is projected at an angle of 30 degrees to the horizontal from the top of a tower of height 160 meters with an initial velocity of 45 meters per second. You are to find the maximum height reached from the ground. B, time to reach maximum height. C, time of flight. And D, range. Now let's look at the solution. Let me use a diagram in representing this. Now let's say this is the tower from which the body is projected 160 meters high. That's the ground level. This is the ground. This is the ground level. And it's projected at an angle of what? At an angle of 30 degrees. And it comes down. So you can see that from here to here gives us what? A height. And from here to here we also still have what? This same height as the height of what? Our horizontal. The angle here is what? 30 degrees. And we have what? The velocity that it was used in projecting it. The velocity is what? 45 meters per second. So we have the velocity, the initial velocity here of 45 meters per second. We have the angle. This is the height of the tower. Now how do we get what? A, our maximum height reached from the ground. The maximum height reached from the ground, let me use capital letter H. It will now be what? This small h here plus our 160 meters. And how do we get this our small h? The value of our small h. The value of our small h corresponds to our h in our parabolic form, which is what? U square sine square theta all over 2g. Then this is now plus 160 meters. Have this as the expression of our work. Now what do we have? This is now equal to, we have our u, which is what? 45 square sine 30 raised to power 2 all over 2 times 10, and this is plus 160 meters. So this will now be equal to what? This is equal to 45 square will give us what? 2025. Open bracket. What do we have there? 1 all over 2. Sine 30 is half raised to the power of 2 all over 20 plus what? 160 meters. And this will give us what? 2,205 all over. When we multiply this, this will give us what? 1 over 4, which becomes what? 20 times 4 plus 160 meters. What do we have? This is 2,225 divided by 80 plus 160 meters. If we divide this, we are going to get what? When we divide this, what are we going to get? First, let's reduce it. Divide by 5. We have what? 4, 0, 5, and all over. If we divide by 5, we have what? 1, 3, 6, plus 160 meters. And this will give us what? 405 divided by 16 to be approximately 25.3 plus 160 meters. So let's add that. That will give us what? 0.35. We have what? 81 meters. So this gives us what? Approximately the maximum height from the ground. The next question they ask us to calculate is time to reach maximum height. The big question is time to reach maximum height. The time to reach maximum height is taken as t, which is given as what? U sine theta all over g. Time to reach maximum height, u sine theta all over g. And this gives us what? What is our u? Our u is what? 45. And sine theta all over what? G. And this is equal to what? 45 times our sine theta is what? 1 all over 2. So this gives us 45 all over 2 times 10 here gives us what? 20. So let's divide that. What do we have? This will give us what? 2 into 4. We have 2 into 5. We have 2. And we have what? Point. We now have what? 5. So our answer is what? 2.25 seconds. 2.25 seconds. That gives us what? The value of our time to reach the maximum height. Now we are going to look at C, time of flight. Time of flight, C. Now, in our time of flight, it's going to take a different dimension because we have basically the time it takes to reach this maximum height, and also the time is going to take from here to this point before coming down. So, but what do? We normally take it in this form. The time it takes to reach the maximum height, which is our small t, then we are going to use the time it will take to drop from this maximum height to the ground. The time it will take to drop from the maximum height to the ground is the same as the time it will take to move from this point down to this place. So now let's look at the time it will take to drop from the maximum height to the ground. Time to drop from what? The maximum height to ground. Let me call that my T2. I want to call it T2. I'm calling it T2. If I'm taking this time, T2, when the body is dropped from that height, what is the height? The height is what? We've calculated the height to be what? 185.3 meters. When the body is dropped from this maximum height down, our initial velocity there becomes what? 0 meter per second. It is now taken as a linear movement when the body is dropped, 0 meter per second. So we want to calculate the time it will take. The time it will take to drop. We already know our G to be what? 10 meter per second squared. We can now introduce a linear formula to calculate that because we are considering the body dropping from this height down. So let's take a linear formula. If we remember the linear equations, we have our H, we have our U, and we have our G. We are looking for what? Our T. We know from our linear equation that X is equal to what? UT plus what? Half GT squared. X is equal to UT plus half GT squared. Now, what is our X here? Our X here now is our H. Our U is 0 here. 0 times T here, it cancels off. Plus We have half times what? 10. And this gives us what? Our T2, which is what? Squared. Or basically our T2 squared. T2 being squared. The time to drop from that height. This is now our formula. So we now have what? Our H here is what? 100 and what? 85.3 equal to what? Half times what? 10 T squared. And we now have 185.3 times 2 divided by what? 10 is equal to T squared. This gives us what? Our value. So let's multiply this now. If we are multiplying, we are going to get what? 2 times 3 gives us 6. 2 times 5, 10, 0 carry 1. 2 times 8, 16 plus 1, 17. 7 carry 1. 2 plus the 1, 3. All over 10 is equal to what? T squared. So this gives us what? 37.06 is equal to T squared. What becomes our T2 squared? This is T2 squared. Our T2 squared will now become what? T2 becomes what? The square root of 37.06. Square root of 37.06. So let's look for the square root of this. 37.06 now gives us what? About 6.08, which is approximately 6.1 seconds. So since we've got that, what is our time of flight now? So the time of flight, capital T, will now becomes what? Our T plus what? T2. Our T plus T2. Now what is the T? We got T, the time to reach the maximum height, is 2.25. And our T2 here, we have what? 6.1. And this will give us what? This will give us what? 5. 1 plus 2 is 3. 6 plus 2 gives us what? 8. We have what? 8. That's the time of flight. And the last, our D, we are asked to calculate the range. Our range, R, is given as what? U squared sine 2 theta all over what? G. U squared sine 2 theta all over G. So what do we have? Now we now have this. Our U here is what? 45 squared. We now have sine 2 times 30 all over what? 10. And this gives us what? 45 squared is what? 2025. And this gives us what? Sine 60 all over 10. What is sine 60? Sine 60 is what? 0.866 all over 10. So if we multiply this, what do we have? 0.5 times 0.866. What becomes our final answer? Our final answer now becomes what? 175.4 meters. That becomes what? The answer.